The next question is, if f of x is equal to x sine 1 by x, x not equal to 0, and 0 when x is equal to 0, then a, fx is continuous as well as derivable at x equal to 0. B, fx is derivable at x equal to 0 but not continuous at x equal to 0. C, fx is neither continuous nor derivable at x equal to 0. D, fx is continuous at x equal to 0 but not derivable at x equal to 0. We first check the continuity at x equal to 0. We know f0 is equal to 0. Now we take up limit delta x tends to 0 of f of 0 plus delta x, which is limit delta x tends to 0, delta x times sine of 1 by delta x, which can be written as limit delta x tends to 0 of delta x into limit delta x tends to 0 of sine of 1 by delta x, which is equal to 0 multiplied by a finite value lying between minus 1 and 1, because sine of any angle lies between minus 1 and 1, which is finite, which when multiplied by 0 becomes 0. Similarly, limit delta x tends to 0, f of 0 minus delta x is equal to 0. This shows f of x is continuous at x equal to 0. To verify derivability of fx at x equal to 0, we take up f dash 0 equal to limit delta x tends to 0, f of 0 plus delta x minus f0 upon delta x. That is limit delta x tends to 0 or delta x into sine of 1 by delta x upon delta x, which is equal to limit delta x tends to 0 sine of 1 upon delta x, which is not well defined as it is not a definite value, as it can have any value between minus 1 and 1. Therefore, it is not derivable at x equal to 0. Thus, it is continuous but not derivable at x equal to 0. Hence, option D is correct. The number of points of discontinuity of fx defined by fx equal to greatest integer cos x plus sin x, 0 less than x less than 2 pi, where vertical brackets represent the greatest integer integral function, options are 2, A, B, 3, C, 4 and D, 5. Now fx is equal to greatest integral value of cos x plus sin x, which can be written equal to greatest integral value of root 2 times cos of x minus pi by 4. It takes integral values at 1 when x minus pi by 4 is equal to pi by 4, that is when x is equal to pi by 2. It takes integral value 0 when x minus pi by 4 is equal to pi, that is x equal to 3 pi by 4. Minus 1 when x minus pi by 4 is equal to 3 pi by 4, that implies x is equal to pi. Minus 1 again when x minus pi by 4 is equal to 5 pi by 4, that implies x is equal to 3 pi by 2. 0 when x minus pi by 4 is equal to 3 pi by 2, that implies x equal to 7 pi by 4. Thus, there are exactly 5 points when it takes integral values, and we know that greatest integer function becomes discontinuous at points where it takes integral values. Hence, the given function has exactly 5 points where between 0 and 2 pi where it is discontinuous. Now, knowing the fact, the graph tells us the graph of fx equal to cos x plus sin x as it goes from 0 to 2 pi as shown, and the corresponding graph of the greatest integer function is also shown in diagram 2. We further note that the greatest integer function of cos x plus sin x is discontinuous at the points pi by 2, 3 pi by 4, pi, 3 pi by 2, 7 pi by 4. Hence, option D is correct. However, the function can be re-described as fx equal to 1 between 0 and pi by 2, 0 between pi by 2 and 3 pi by 4, minus 1 between 3 pi by 4 and pi, minus 2 between pi and 3 pi by 2, minus 1 again between 3 pi by 2 and 7 pi by 4, and 0 between 7 pi by 4 and pi.